Across the food manufacturing, labor availability, industry trends making manual or semi-automated production unsustainable. What are we talking about? Basically, it's labor. Labor is a huge challenge across, whether it's baking or any food manufacturing, but labor, facilities cannot find enough labor to fill the roles consistently, especially the overnight or high care shifts. We're also facing wage and turnover rates as they continue to climb, making manual operations more expensive and unstable. Consumers expect consistent, high-quality products, and retail customers demand tight specifications. Robotics are the answer as they offer a path to stable production, repeatable quality, and predictable output, even with tight labor markets. Food handling robots also have become more available and attainable, which help us optimize our processes. In addition to robotics, additional accessories along to robots, i.e. vision and sanitary designs, gripper flexibility, make it easier for us to automate in a food environment that we couldn't do just a few years ago. Additionally, prices have dropped as demand has increased, making ROIs achievable within a 1 to 3 year for many bakeries and operations. Also, the technology of the robots has changed. We now have more food ready, washdown rated, hygienic design, and robots compatible with food contact zones. In short, robots are no longer a futuristic ideal. They're practical tools for today's operations. So, what I hope is you can leave today with an understanding of one, how robotics can optimize a bakery process line, some things to keep in mind when adding robots, and making the most out of your robots. As was mentioned in my intro, I'm Ryan Park. I'm Director of Sales and Marketing for SPI Automation, a division of the Grody Company. I have over 30 years of system integration experience, majority of that time designing, installing solutions, and in the last several years selling and helping customers recognize the savings that they can see by automating previously automated processes. How can robots help? Automation in general, but robots allow us to do things that we couldn't do before. They can lift, they can repeat, they show up to work every day. They provide scalability that was otherwise unobtainable because of the labor challenges that we face. So again, why do we need robotics? I believe the number one is labor availability and the cost of labor. Second, product consistency and quality control. Being able to do and repeat things more cycle after cycle without the human touch. Throughput needs. In an ever increasing demand for more throughput, more production, it's harder and harder for human operations. Supply chain and cost pressures. We need to produce more for less. Again, that goes back to labor. How do we relieve cost from the manufacturing process? Food safety and hygiene, that's an ever increasing challenge as well. Our consumers demand more food safety and the risk of disease or sickness. And then technology advancements and affordability, as mentioned, the robots are easier to obtain. There's more options, there's more variety, and then consumer and market trends also drive the need for flexibility, which robots allow us to provide. Robotic applications. What's a good application for a robot? Repetitive tasks. Things that we can do over and over and over. Low value tasks. Items that require in our manufacturing process that are tedious but don't provide a lot of value, but if we have labor doing that, they become very expensive tasks. So if we can automate and use robots for that. Unfavorable conditions or unsafe conditions. So in a lot of bakery or manufacturing, it's hot, it's humid, it's miserable, or we're dealing with hot pans, hot product, high speeds, moving components. So there's a lot of unfavorable and unsafe conditions which make it ideal for robotics as well. Historically, in robotics, in the manufacturing, in bakery and food, we started seeing a lot of robotics and automation in the general material handling, case packing, palletizing, warehouse, supply chain, product transferring. It was easy to automate in those areas. The rates were lower. There was less risk to the product. It was already in its packaging. You didn't have to worry about cross-contamination, and it was just easier to see automation. So there's a lot of automation in that area of the factory, but with the addition of new technology and the robot and sanitation, we now can move upstream into the primary food handling, automating a high care, which is a traditionally manual and tedious task, as well as the technology it makes and the pricing making it much more attainable. It really is time to consider what else you can automate in your bakery line. A bottom line to that is the cost of doing nothing, meaning lost labor, waste, inconsistency, often outweighs the cost of the investment in the robot. Considerations, some things to keep in mind. Let's talk through those. Major factors of adding a robot to your bakery processing line. What is a viable application or process? This is part of a conversation and discovery with your partner. Not everything is going to be an ideal application for automation, even today with the things that we've already talked about. Some other things to consider are what the equipment footprint and the layout will look like, as well as operation and maintenance. Is it easy to operate? Is it easy to maintain? And is it easy to clean and sanitize to the demands of your production requirements? So we're talking about moving upstream into more of the high care bakery applications. This is primary product handling and transferring. We can talk about depositing and portioning, product assembly, decorating and finishing. For example, primary product handling, we could talk about moving cupcakes and muffins, breads. Depositing and portioning, we could be depositing sauces, icing, sauces, product assembly, sandwich assembly, picking and placing, layering, and then decorating and finishing are also some options. Here you can see some robots working in a product handling and transferring. This is a system example, depanning muffins or cupcakes at a high rate of speed. This is also an example of where you could say it's unsafe or unfavorable for people. This is a high-speed oven. It's high, it's wide, people can't reach it. The oven is hot, the muffins are delicate, and you also need to pick and transfer it directly into the packaging. So that's an example of a couple of robots working in conjunction with each other to complete a turnkey solution. Another example of product handling and transferring. Here you can see a robot handling at a high rate of speed, picking and placing tortillas. This could be pizza, could be buns, it could be sandwich slices, a lot of different things. A lot of technology available for us in our end-of-arm tooling, vacuum, grippers, pins, a lot of things that we can do that we couldn't do before, where we can directly touch the product right before its additional value-added steps are completed. Depositing and portioning. Here you can see some robots handling some tortilla wraps, moving the product into position for downstream slicing. But these are tasks that if you just have a normal person doing it, doesn't add a lot of value to the product, just adds a lot of cost to the product. So automating those make good choices. Sandwich assembly, another example. This is a completely automated line where you've got bread denesting, you've got slice and apply, you've got saucing, you've got manipulation, product stacking, orientation. So there's, again, lots of opportunities that we were not considered before automated. We can now automate with the complex tooling, quick change tooling, and then also just the speeds at which the robots and the sanitation of the robots allow us to now find solutions for. Another application, decorating and finishing. This is another great solution for automation. This would require lots and lots of operators. Again, this is a safety situation. I happen to know personally this one, there was a lot of carpal tunnel issues with the decorating, as well as just a high speed, and then just the need for a repeatable process. If you put dozens of people trying to write the same script, you're going to get dozens of different outputs. So this was a good opportunity to, while working closely with a customer, provide a high speed, highly repeatable, remove a lot of safety and risk, and really up their production while also reducing the cost per product significantly. Footprint and layout. We talked, this is one of the things that we should consider when we're looking at robots. No one size fits all solution. No bakery layout is the same. Everyone's different. So you want to work with someone who can work hard to find a solution that fits your process, can design for flexibility to maximize the space. Do we have 3 dimensions to work with? Looking for compact systems, can we do things modularly? Can systems be moved in and moved out for different changeovers? And how do we integrate with the surrounding equipment, be it vision systems, to locate product, orient product, and what is the most efficient way to use space? Also, when considering robotics, we should look and consider the operation and maintenance. Aside from the task at hand, I think these are 2 very important things to consider. Is it easy to operate? If it's easy to operate, then the operators are your champion and you're going to have a good success. Also, if it's not easy to maintain, then it's also not going to be looked well on the floor. Nobody wants to have a difficult machine for operation or maintenance. Controls, single point of controls, the ability to do long runs, data collection, being able to use those tools both for the operation and for predictive maintenance and predictive production requirements. Sanitation and cleaning, another hugely important. Again, we talked about robots on the material handling side, case packing, palletizing. Those robots are not necessarily needed to be cleaned and sanitized. Now we're looking at robots that are handling directly with the product. Are the tools easy to clean? Are the robots easy to clean? Can they be washed down? Can they be sprayed? What is required? Again, look at the application, because not every application requires a completely wash down, spray down robot versus is the tooling easy to clean? Is the tooling easy to change and take off? Maximizing your robotics opportunity, getting the most from your investment. We're talking ROI is the first thing to consider. Do we pay for itself with labor savings? But really it's a long-term investment, and you should be looking at it from that perspective as well. What is the true cost of ownership, and what do I gain from using robots in my application? When looking at and considering robots as well, pull the team together. Engineering, operations, maintenance, quality assurance, product development, food safety. Everybody looks at this solution a little bit differently. What does engineering want? They're going to be looking for structural, they're going to be looking for reliability. Operations will be looking at it from ease of use. Can I teach my people how to use it? Is it scary to them? Maintenance is going to be looking at it. What does it take to maintain? our spare parts, we're using common components, quality assurance, these are the reliability, food safety, and product development are going to be looking at it a little bit differently as well. So really generate a team and get some input from everybody, which is also part of the planning aspect of it. What's important in the operation is are you running one product that's going to run all the time, or are you going to have line flexibility? If it's line flexibility, do we know all the parameters? Can we do quick change tooling? Do we need multiple robots? What are the inputs to the challenge, and how do we calculate what is the best result? What is uptime, downtime, maintenance time, and once it's running, are we building momentum for the next steps in the process? So one thing to consider is, do we look at the whole problem today and come up with a solution that costs a lot of money and may be difficult to recognize ROI and recognize a successful plan? Or is it better to pick off a small piece of the problem and generate a solution that buys us some ROI, buys us some investment, and then we can move to the next step and automate it? Maybe we can move to the next step as additional technology and resources become available, and we pick off small wins to ultimately automate the entire line. Again, we talked a little bit about total cost of ownership. What is the initial cost, the cost of operation, the cost of maintenance, cost of downtime, cost of production, and really what is the end result is, what does it cost? So all those things should be considered when considering a robot and the automation as well. Implementation. I think this is also, a real key point. You want to work with the right partners, and the right partner, if we're talking about food and robotics, is somebody who works in food and robotics, not just general robotics as a rule. Work with somebody who's been in the food industry, understands sanitation, understands cleaning, understands that environment. Somebody who has a robust partner network. What are their resources? What are their footprints? Are they able to be there for me if I have downtime issues? What is their spare parts process? What is their documentation? What is their ability to provide ongoing support? Are they going to be there tomorrow for me? And do they offer additional capabilities? Can they provide additional conveyors? Can they provide layouts, installation support, control support, system integration, etc.? So there's a lot of things that consider by finding the right partner for the solution as well. Another good step is, we talked a little bit earlier about building a team, but you also want to empower your team for long-term success. It's really about creating a strategy, not just an individual project. We want to train people. We want to get, one of the things that quite often is offered as part of the solution is like robot training, sending some people off to robot training, getting specific training on the end-of-arm tools, on vision systems, all the things that become part of the solution. You're really trying to elevate the technical team that supports this, and we do that by providing continued education and really just building a culture of innovation and growth. Like if you put the system in and have a team that's built around support, then you have champions all around. If you don't do that, then you have a bunch of negativity, or the robot isn't working, the robot's down. But really, if everybody's invested, then everybody has a vested interest in keeping the system running and seeing it as a productive use of a productive tool. So basically, as we wrap up here, food handling robots build efficiency, eliminate the cost and risk of manual handling on bakery lines. That's what it's about. We're trying to find solutions where we can find repetitive operations, difficult things to do, safety risks, and really automate those out of the process. And then to form a plan of success, Really, it's planning ahead, finding the right solution, the technical supplier, and looking for somebody who can help you maximize long-term success. And appreciate it. That's the end of it. So thank you. I probably rushed through that a little too soon, but if there's any questions, happy to address them. Yes, sir.
Kind of interested in the human element of the
Yeah.
automation. You talked about training. So where at a factory floor, the 100 machines right at birthday on things, what is the human component? Is there one person in a control room, or 3 people in 8-hour shifts? And are those people process engineers? Are they IT people? Are they high school grads, which is the basic training? What's the staffing for something?
Sure, that's a good question. So in the cake decorating application in general, that particular customer sent 2 engineers to robot training to become efficient with the language behind the robot. But the real champions for that were their production supervisors. So they ran a 3-shift operation, and each shift had their own production champion who learned everything about the line from start to finish. That took, what did it take, what buttons to push, what levers to pull, what was the right icing, temperature, all the things that would go into a custom solution like that. They became the champions to the solution. Today, the way we design and build robots, we try to dispel the need that this is so technical that I have to have an engineer on site to operate, okay? We design the robots themselves, their language, are built in a way that if you understand a little bit of robot language, we're really just using standard PLC programming to say, we want to go to point A, and the robot says, I'm at point A, what do you want me to do? So it makes it a lot simpler for the people on the factory floor who are already used to maintaining PLC driven systems to not have to be robot engineers to run these systems. Is that
blue collar enough that it's
so?
intentionally organized labor? You talked about total cost of ownership.
Yeah. So that's the other nice thing that's coming out of this, right? So 10 years ago, that was probably a lot more engineer-based, 4-year degree type people that would be in this advanced position, and we were making the systems were a lot more difficult to maintain and run. Today, it's high school graduates. There's a lot of robots that are now being put directly into high schools from a training standpoint. But you really get into the tech college side of things, most everybody has a robot. So we're talking technician level programming and operation for these people. Yeah. Yep. Thank you for the question.